The focus of my research is about the interface between biological matter and inorganic material. And they're two materials that have very different properties, yet the interface between them is really important in lots of naturally occurring high-performance materials. For example, bone, teeth, seashells. And the way in which these materials have such fantastic properties is all down to the behaviour of this interface between biomolecules in the shells or the teeth and this inorganic component. We want to investigate these properties at the molecular level, so we use computer simulations to probe the structure, dynamics and behaviours of these interfaces. So I see this research progressing in a way that will enable us to make materials, new materials that have novel properties in a way that's actually environmentally benign and safe in terms of workplace safety, and also would be amenable to recycling.
So what Tiffany's trying to do is to establish how we can better physically connect inorganic material and organic material.
Deakin has a very simple motto for our research. It's research that makes a difference. I've been very keen for the last 5 years to try and find what I call a modern chemist. A chemist who can actually work at this sort of, in this new space where we're looking at new materials, biological systems and modelling. What Tiffany's research does is actually go back into a particular biological system and through her modelling explain to us why certain things are happening.
I was really attracted to come to Deakin, particularly the Institute for Frontier Materials, because there is so much going on there right now. There are so many academics that I feel like I can collaborate with, and the research that's going on there is so exciting.
She comes from a background in the UK, having been at some of the world's best universities at Warwick, Oxford and Cambridge. Her work will inform the design of new materials and how they are applied in medical systems, for example, implants or prosthetics. And her work will help understand how biological tissues, for example, interact with those materials.
One of the advantages of having somebody like Tiffany in the community is they serve as a very good role model to students. They can go on and use computer modelling in conjunction with experiment to drive the life sciences, which is such an important thing in Victoria. VLSCI is an initiative funded by the state government and the University of Melbourne, and the aim is to bring the power of computation to the life sciences.
Because a lot of my work is concerned with biomolecules, it was a perfect fit in terms of my research program with the priorities of the VLSCI. It was such a big draw card for me to come and be able to use this facility. And for me, I saw this as a chance to really invigorate my existing research program and just begin to sort of grow new research in any number of directions. It's really exciting.
One of the key accomplishments of VESKI is that it helps us attract and retain the very best researchers. We need to get the best because we need to be the best.
Without a doubt, the VESKI Fellowship is really what made this possible, and it's just been a complete thrill to be selected as a fellow for 2012.